Yeah, hi everyone. So in this video we discuss a little bit on how to write a report, and at the same time we do some discussion about or some briefing about the next experiment, which will be experiment 4. Okay, first we want to go through about the lab report first. Okay, so one of my class we already discussed up until graph. Okay, then another class I think already discussed up until conclusion. So in this video I want to repeat a little bit. So we're going to start from the calculation part, and then we're going to go through the discussion and conclusion. There might be slightly changes compared to previously I told you before. I try to make it as simple as possible. Okay, so this one is actually example of report from my previous student. So this one is experiment from semester 2. So it's nothing to do with your experiment yet. Okay, so what I want to point out is in terms of calculation. Okay, so the first thing that you're going to start is about centroid. Okay, so this one normally you don't have any problem. Okay, so again, like I told you before, make sure when you write down you use the actual decimal place. So in this example they have 2 decimal place over here, so they copy back the 2 decimal place, and this one 1 decimal place, so this one should be 1 decimal place. Okay, this one is 32.0. okay, and this is the final answer. Straight away you gonna plot this point, and then you're gonna draw a graph. Okay, so after you complete the graph, you draw the triangle, and then you label on the triangle to calculate the gradient. You label the coordinates. After that you have to calculate the gradient. Okay, so the gradient here you have to write down the formula first, and then substitute all the equations. And if you want to write the unit, you can write it over here, or if everything in SI unit, final answer will be in SI unit as well. If it is not in SI unit, make sure you double check how the unit cancel out and so on. Okay, and then after that, after you calculate the gradient, what you guys need to do actually is that you have to do a table to compare theory equation and linear graph equation. So what I mean is something like this. Okay, but my student here, they didn't use, she didn't use a table, but I want you guys to write inside a table instead. So basically you have a linear graph y, m, x and c. Okay, so that one is actually inside a table like this. So I want you guys to compare with the theory equation. So equation that is in theory part. Okay, and then you're plotting v equals to ir. So you're plotting graph of v against r. So your y-axis represent your voltage. I compare with this one, yeah. The gradient represent the r, and then the x is actually current. Okay, so I just go to the graph here. So she was plotting v against I, so v is your y and x is your I. So here you can see that the gradient is actually equals to r. So I strongly suggest you to use the table. Okay, and then after that, once you compare from the table, you have to find the values that the objective want to find. Okay, in this case they want you to find the r in this experiment, my student. So you have to write down how do you relate m with the r. So in this case m is equals to r, so straight away m equals to r is this value. Okay, and then after that you have to state or calculate theoretical value. So if you have to calculate, then you have to show the working on how you calculate the theoretical value. Okay, if you don't have the if you don't need to calculate, you just simply have to state. Example, you can state that the theoretical value for g is 9.81 meter per second square. Okay, and then lastly, for calculation part, you have to do percentage error. Okay, percentage error is this one. So basically, it is theoretical value minus the actual value and then divided by the theoretical value. This one is not actual, this one is more like experimental. So I change this one to experimental. And make sure when you try to write down, you use the appropriate symbol. So like this example, actually they compare the values of R, so use R instead of X. And then final answer, just write it down into decimal place. Okay, so in terms of discussion, so first thing first, you have to state the results. So after calculation, you have to do the discussion. Okay, inside the discussion, number one, you need to state the result obtained from the experiment and the theoretical value as well. Okay, and then after that, you have to state percentage error, state at least 2 precaution and at least 2 source of errors and suggestion to overcome them. Okay, now the first thing first, actually you have to write down the value that you get from the experiment, which is this one. The value of effective resistance of the series circuit is 81 ohm, and or you can say Y lah. Theoretical value is maybe I can write it down over here. Is, in the example, theoretical is 81, so you have to state as well. Okay, so I think the values of effective resistance of series circuit from the experiment is, or from the gradient, is 73.08. Okay, so basically you have to state the value that you get from the experiment, okay, and then the theoretical value here. Okay, just state. Okay, this one got 1 point, this one got 1 point. After that, you have to state the percentage error. So that one is the next one lah. So normally they don't penalize with the how to say, with the numbering. I mean, they don't normally penalize whichever comes first lah. You can write percentage error first, and then after that you write down the values for experiment and theoretical. Okay, and then this one you don't have to write, so just cancel it out so that you don't get confused. Okay, so these are the 3 marks that will be given first inside the discussion. So 1 mark here, 1 mark there, and then 1 mark there. Okay, so 3 marks. Okay, after that you have to state at least 2 precaution. Okay, I don't want to go into detail. I mean, this is a different example, so I don't want to go through this example as precaution. I just want you guys to think on your own, but this is an example lah. Okay, you can read it if you want to. And then after that, make sure you write down at least 2 pairs of error and suggestion to overcome. Okay, this one is precaution, this one is suggestion to overcome the error. So these 2, my student here write down 3. I strongly suggest you to write down 3. I think she write 2 only. Okay, sorry. So at least 2. And make sure these 2 are not related to these 2. There's nothing to do with that one. Okay. Example over here is parallax error. So if you say it is a parallax error, make sure you write down in details parallax error when reading what. Okay. And then overcome for parallax error, your eyes must be perpendicular to what scale, which scale. Okay. And then this is the second errors and on how to overcome. I'm not going to touch that one because I don't think it's related to you yet. Okay, and then the last part is about conclusion. So you have to state clearly with correct unit based on the objective, the final values of experimental that the objective want you to find. Okay, so in this experiment the value of resistance is 73.08. Okay, so this is actually the only value that they want to check lah, 73.08 ni. And then if the objective of the experiment is to verify a certain law or certain equation, you have to state that it is verified. So conclusion here got 2 marks. Okay, one from this one, another one come from verified. So this verified or not verified determined by the shape, or sorry, by the type of the graph. So when you plot the graph in this example, you get a linear graph. So linear graph here agrees with the theoretical that you will get a linear graph. So as long as it agrees, your experiment is verified. Okay, so most of the time it's verified lah, unless suddenly you get like in opposite direction like that, so maybe you can say that it's not verified. Okay, that's all for the report. So remember, calculation, and then after that discussion and conclusion. It's very simple, very straightforward, but you have to put some effort on how to write down the precaution and errors and the source to overcome. Okay, please think properly whether it makes sense or not. Okay, now for the next experiment, which is experiment 4, rotational motion of a rigid body. So you have to watch on how to set up the experiment. So make sure you watch the video before you enter the class. Okay, please. Okay, objective. Okay, I'm not going to go through the theoretical part. Maybe I go through a little bit. So what happened here is that this object will pull it will pull this pulley in that direction lah. So it will go down like this. Okay, if you are focusing on this as our object, as our body, so here you can see you have two force, which is tension that is pulling it in this direction, and then it has a friction as well. Okay, so if you are talking about this one, if you want to draw the free body diagram of these forces, you can write down the equation. You get this equation, summation of F equals to MA. It's actually Fy lah. So it will be weight minus tension. So this is the equation. So rearrange, you get this equation. After that, actually they use summation of torque equals to I alpha, because this one has alpha, dynamic equilibrium. You haven't learned yet in tutorial. You learn I think this week. And then there are two torque actually acting on this flywheel. Okay, one is tension, torque due to tension. Other one is torque due to the friction. So the one in the same direction with alpha minus the one opposite direction with the alpha. So you get things like this. Okay, so actually the actual formula for torque is actually RF sine theta, but the theta in this case is 90 degrees. Again, I'm not going to go through details here, but we go through details in tutorial. So substitute back, you get this. Okay, this is the equation 4.2, and then rearrange by alpha is equal to something, so divided by I, you get this equation. Okay, so this is actually the one that you will compare with the linear equation. So the one that you have to do the table later on, you have to compare this value. Okay, so do inside a table lah, this table. Okay, and then you will be plotting. If you go through the, I'm going to skip a little bit. Okay, you will plot graph of alpha against t. So alpha is your y, t is your x. Where is it? Y, t is your x. Okay, and then the gradient you get r over I. Okay, rearrange, you get I is equals to r over gradient. So go back to the initial objective here to determine the moment of inertia of flywheel I. Okay, so basically they want you to determine the values of I. So from the gradient you can find the I, that one would be the experimental value. Theoretical value, I will give you, I will write inside a telegram lah. Okay. And then this one from the linear equation. Okay, you can rearrange and you can write down all these values here. I mean, you can go through slowly lah if you want. And then you get this equation. Okay, and this equation as well. These two equations will be very important. You will see when you can use it. Okay, now after that you have to set up the apparatus as in figure 4.2, which is this one. Okay, so again, please watch the video of demonstration beforehand and then set up something like this. Oops, pay attention to the values of R and value of H here, how to measure the R and H. Make sure you measure it correctly. Okay, where is the measurement for R from the center and from that part. Okay, H bottom to the floor. Okay, and then the first step they ask you to do after you set up the apparatus is measure the D and R. Okay, record the falling sorted mass of M. So when you release, obviously it will fall down. It will fall down, and then record the falling sorted mass. And then choose a fixed point at a height H above the floor. Record height H. Release the sorted S M from the fixed height. Okay, and then record the time. Okay, so after that you repeat the experiment, right? How many times? Repeat step at least 6 different slotted mass. Okay, at least 6 huh? And then they want to calculate linear acceleration from equation 4.5, 4.1 and 4.6. Okay, linear acceleration A, T and alpha, equation 5, 1 and 6. Equation 5, okay, you can calculate A. Equation 1, you can calculate T, tension. And equation 6, you can calculate the alpha. Okay, because you want to plot alpha against T. Okay, determine the moment of inertia of the flywheel. Okay, this one is what you have to find lah. This is the objective. Okay, 12 you can ignore. Uncertainty, ignore. And then compare the moment of inertia flywheel to the standard value. So this is actually standard value, is experimental value lah. Sorry, theoretical value. I will give you in Telegram, theoretical value. Okay, so before you enter the experiment, make sure you already done this. Okay, or the pre-report, you have to write down the name, date, title, objective, theory, apparatus and procedure. And then you have to do the data tabulation, the table of the data beforehand. Okay, so this is the table. I help you a little bit because I'm not inside the class. So this is the thing that you gonna record and measure. Okay, the mass and the time taken. So obviously when you measure the mass, it need to have the uncertainty and the unit. The time you measure, again, it need to have uncertainty and unit. Okay, and then this is the T average. So basically T1 plus T2 divided by 2, you get this value. Okay, and this is just a square of this value. Okay, make sure you be careful with this decimal place over here. Okay, and then this is the T square of this value, and then you can find A. How to find A? You can go back to equation 4.5 here. A is equals to 2H over T. So basically you need to have a value of H as well, right? Okay, and then so maybe you can write down the values for H over here. So that I understand what the things that you calculate. Okay, this is the unit. I'm not sure what is the unit. Okay, and then after that, you can calculate the alpha. Okay, how to calculate the alpha? You can use equation, this one. Okay, since you already have the values for A, you can substitute inside here for each different mass, you have a different A because you have a different T, right? So from there you just divide with the values of R. Again, you have to write down values for R as well. Okay, so I'm gonna bring this one lower so that I have enough space to write down the R as well. Okay, write down with the correct unit. So if you notice before this, the first thing that they ask you to measure is actually DR and H. So I expect you have D as well. Okay, so basically you measure the D and then you calculate the R by divided with 2. Okay, because that one did not calculate, you just have to write down the unit. Okay, after that, the last part is you have to calculate the T. T comes from the formula 4.1. Okay, so you can calculate T from here, and then you have values of T and alpha. So you're gonna plot graph of alpha against T. So calculate the centroid. After that, alpha against T. Okay, and then so on, and then continue. Okay, I think that's it. All the best.